All right, so we've got ourselves another regular polygon. This time it's a hexagon, again inscribed in a circle. We have the diameter is 32 units. We want to find the area of this hexagon. So in my last video, I had mentioned a strategy that we're going to use, which is to divide the polygon into several right triangles. And you can already see that one right triangle is here, and so we'll just continue that. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so we have 12 right triangles. Okay, within this hexagon. So here's the thing, right? If we can find the area of one of those triangles, right, then we would just have to multiply by 12 to get the area of the whole polygon. All right, so let's focus on one particular right triangle, and I'll just highlight it to draw your attention to it. So we're going to look at this one right here. Okay. So what do I know about this particular right triangle? Okay. Well, I know it's got a 90-degree angle there. Okay. Because the diameter is 32 units, right? Half of that would be 16, right? So the hypotenuse on this right triangle would be 16 units. Okay. Now there's one other thing I can figure out about this triangle, which is I want to know its central angle. Okay. Now remember, if we add up all the angles here, that would be 360 degrees, right, for the full circle, if you will. And then because we've divided that into 12 equally sized right triangles, right, let's divide 360 by 12. And what is that going to be? 30? Just double check 360. Yeah, so 30 degrees. All right. So we know that that acute angle there is 30 degrees. All right. So let's just look at that green right triangle. And I'm going to just redraw it laying down on its long side. So you have a right angle there. The hypotenuse is 16, and the acute angle is 30 degrees. Okay. Now remember, we want to find the area of this right triangle, and then we'll multiply by 12 to get the area of the whole polygon. Okay. Well, it's a triangle, and the area of a triangle is 1/2 base times height. Okay. So now we've got to figure out the length of the base here and the length of the height there. Okay. And all we have to go off of is the length of the hypotenuse. But since we know the angle, we could use a little trigonometry to figure out the other two lengths, right? You knew deep down inside that we were going to come back to trig. Okay. So now is that moment. All right, so here's a couple trig ratios that you should remember, right? The sine ratio of an angle is the opposite side to the hypotenuse. And the cosine ratio for an angle is the adjacent side to the hypotenuse. Okay, so 16 is our hypotenuse. Let's go ahead and label that. Okay, the side here on the bottom is adjacent, right? It's next to the angle 30 degrees. And then the short side here is the opposite side. It is across from the angle 30 degrees. Okay, so let's go ahead and start plugging away. All right, so we'll write the sine of 30 degrees equals OPP over 16. Yeah. And then we can multiply both sides by 16. And we get that the opposite side is 16 times sine 30. Okay, so when you're doing this on the calculator, make sure you're in degree mode. Okay, 16 times the sine of 30 degrees. Oh, it's 8. How nice. Okay, so let's go ahead and label 8 in our figure. And then let's go ahead and plug away into the cosine formula. So the cosine of 30 degrees is adjacent, which I don't know. So I'll just write ADJ over hypotenuse 16. Okay, it looks like we're going to solve the exact same way by multiplying both sides of the equation by 16. So the adjacent side is going to be 16 cosine 30. 16 times the cosine of 30. Okay, and that number isn't so nice, right? The first length was 8. This is, you know, a decimal value. So here's what I want you to do, right? Because I'm clever, I'm sure it's going to say probably round your final answer to 2 decimal places. So since this is not our final answer, I'm going to round to 4 decimal places. I'm just going to be a little extra, okay? That way nothing funky happens, right? Because if you round too early, then that rounding could compound. And then when you get to your final answer, it's going to be off by a digit or so. So I'm going to round 4 digits now. And then when I get to my very last answer, then I'll round to 2 digits. Okay. So I'm going to record this as 13.8564. And we'll write it here. 13.8564. Okay. So for this right triangle, right, we now know the length of the bottom of the base and the length of the side or the height. And so we can calculate the area of this triangle. It's going to be 1/2 times 13.8564 times 8, which is going to be 55 point, and again, I'm going to go 4 decimal places since this is not the final answer, 55.4256. Okay, so that is the area of just one right triangle. So because the polygon is made up of 12 of these right triangles, right, we're going to multiply that by 12 to get the final answer. Okay, so times 12. And now since this is my final answer, I'm going to round just 2 decimal places. Calculator says 665.107, so we'll round that to 0.11. And since this is area has 2 dimensions, so it's units squared. All right, so to recap, what we did is we took our polygon, we divided it into similar right triangles, congruent right triangles actually, and then we found the area of just one of those right triangles. We had to use a little trig to find the length and the width. Okay, and then the triangle area formula, 1/2 base times height, and then multiply that by the number of triangles that make up the polygon. All right, cool. Thank you so much for watching.